Imagine it happens tomorrow. A press conference. NASA, ESA, every major space agency on Earth. Standing room only. The director steps to the podium and says 6 words that change everything. We have confirmed intelligent life exists. The signal came from a star 800 light-years away. It is structured. It is unmistakably artificial. It is repeating. The civilization that sent it is real. The room erupts. Every screen on Earth shows it within the hour. 8 billion people feel, for the first time in history, that we are not alone, that the universe is not empty, that somewhere out there, another mind is looking up at the same stars. Now do the math. The signal left that star 800 years ago. It was sent in the year 1225. The Knights of the Third Crusade were still alive when it departed. Genghis Khan had not yet died. The Black Death had not yet arrived. By the time our reply reaches them, it will be the year 3025. Every person alive today will have been dead for 1,000 years. And that is the closest scenario. That is the good version. Now consider the bad version. Not a star 800 light-years away. The nearest star system, Alpha Centauri, just 4.2 light-years from Earth. If a civilization existed there and sent a signal today, it would reach us in 4.2 years. We could reply. They could receive our reply in another 4.2 years. A genuine exchange, a real back and forth, would take at minimum 8 or 9 years per round. In a human lifetime, you could exchange perhaps 4 or 5 messages. Not a conversation, not diplomacy, not science. 4 or 5 messages, each one arriving when everyone involved in writing the previous one may have moved on, retired, or died. An Alpha Centauri, the closest star system to our own, shows no evidence of being inhabited. The closest confirmed potentially habitable planet discovered there, Proxima Centauri b, orbits a red dwarf star that periodically blasts its surface with ultraviolet radiation at levels hostile to life as we understand it. The nearest potentially habitable world may be closer to 20 or 40 light-years away. A round-trip message time of 40 to 80 years, long enough that the person who sent the message would be elderly or dead before the reply arrived. We have been listening for 65 years with the most sensitive instruments ever built. The most comprehensive search in human history has returned one candidate, a 72-second signal in 1977 that never repeated. Against 400 billion stars, across 13.6 billion years of galactic time, that is the entire harvest. The silence is not an absence, it is a verdict. And the verdict, when you follow it carefully through the physics, through the evolutionary biology, through the game theory, through what it means that we are here and they are not, points at something that concerns every person alive on this planet right now. Get comfortable. Subscribe if you are new here. By the end of this, the quiet is going to feel different. Now, let us begin. Before we go further, one number needs to land properly. 400 billion stars. That is the conservative estimate for the Milky Way. If you counted 1 star per second without stopping, the count would take 12,675 years. The Roman Empire would not have been founded yet when you started. It would have collapsed and been forgotten, and its ruins grown over and its languages died before you finished. That is 400 billion stars in one galaxy. The observable universe contains an estimated 2 trillion galaxies. When Fermi asked where everybody was, he was not asking about a small sample. He was asking about the output of a system that has been running for 13.8 billion years at a scale that no human intuition is built to process. The silence that system has returned is not a small silence. It is the quietest thing in physics. The Fermi paradox is not a philosophy puzzle. It is a missing persons report for an entire galaxy. You've probably heard the casual version. The universe is vast. There are billions of stars. Surely there is other life out there. So where is everybody? It gets raised at dinner parties and set down again when someone refills the glasses. It sounds like a comfortable mystery. That framing is wrong, and the wrongness of it matters. The Milky Way contains between 200 and 400 billion stars. The Kepler Space Telescope, which ran from 2009 to 2018 and surveyed roughly 150,000 of them, found that planetary systems are the rule, not the exception. Current estimates place the number of potentially habitable planets in this galaxy alone at somewhere between 10 billion and 40 billion. Take even the most pessimistic fractions for each subsequent step toward technological life, and you still arrive at thousands of civilizations in this galaxy, present or past, by the math. Now apply one more fact. A civilization that arose anywhere in the Milky Way even 500 million years before us. And 500 million years is a rounding error on the galaxy's 13.6 billion year age. And that civilization expanded at even 1% of the speed of light would have filled every star system in the galaxy roughly 50 times before we evolved. Their traces would be everywhere. Their signals would be inescapable. Their presence would be the dominant fact of astronomy. We have found none of it. Enrico Fermi understood this at a lunch table in Los Alamos in 1950. He was one of the most precise quantitative minds of the 20th century, and he ran the numbers in his head, while his colleagues were still laughing about a cartoon. Where is everybody? He did not mean it as whimsy. He meant it as an equation. The math says they should be here. They are not. Something in the picture is wrong. In 1961, Frank Drake at the National Radio Astronomy Observatory in Greenbank, West Virginia, wrote an equation on a blackboard. It has since been called the Drake equation, and it is almost always described as a tool for estimating how many civilizations exist. That is not what it is. The Drake equation is a machine for exposing what we do not know. Every term in it is uncertain by orders of magnitude. What it does is define the shape of our ignorance, showing you exactly which questions must be answered before any claim about how common life is can be made honestly. The final term, L, is the one that matters most tonight. L is the average lifespan of a technological civilization in years. If L is small, if civilizations are typically short, the silence makes sense, not because they were never there, because they are gone by the time we look. The question of what makes L small, what ends civilizations, is the question the silence is asking. Here is where the compressed timeline makes this visceral rather than abstract. If Earth's entire 4.5 billion year history were compressed into a single 24-hour day, life appears at around 4 a.m. Complex animals arrive at 8:30 in the evening. Modern humans appear in the last 3 seconds before midnight. Our entire written history, everything from Mesopotamia to the present day, fits in the last quarter of a second. Radio technology, the thing that makes us electromagnetically detectable, arrived in roughly the last millionth of a second before midnight. Our communicative window, the period during which we could theoretically be found or find others, is 0.0027% of Earth's existence, less than 3 millionths of 1%. If two civilizations in the galaxy are going to overlap in that window, their windows have to coincide within that fraction of their total histories. At the scale of galactic time, a civilization that lasts 1,000 years is invisible. One that lasts 1,000,000 years is a thin sliver. The question of whether two slivers spread across 13.6 billion years happen to overlap is not a question with a comfortable answer. Let that percentage become physical. If you printed the entire history of Earth onto a standard roll of toilet paper, 1 sheet per 1,000,000 years, you would use 4,500 sheets. That is a roll stretching about 45 kilometers. Modern humans appear on the last quarter of the last sheet. Our radio capability is a thin stripe of ink at the very edge of the last quarter of the last sheet. That stripe is what we're asking another civilization to overlap with, across 400 billion stars, across a 13.6 billion year history, during which any of them might have had their own stripe at any point on their own 4,500 sheet roll. The timing problem alone, independent of distance, is severe enough to explain the silence without requiring any other cause. Two civilizations whose electromagnetic windows do not overlap in time are effectively non-existent to each other, regardless of how close they are in space. A civilization that arose on a planet 200 light-years away, reached radio technology 10 million years ago, and went electromagnetically silent 99 million years ago, would have left a signal sphere that expanded past us 9.9 million years ago and has long since propagated beyond our reach. We would have no way of knowing it existed. The Fermi paradox is not a puzzle that needs more data. It is a constraint that current data already imposes. The silence is already speaking. We have been listening for 65 years. The question is whether we are willing to hear what it is saying. The astronomer Frank Drake, whose equation has framed every serious discussion of the Fermi paradox since 1961, spent decades running CT searches and thinking about what the silence implied. In a 2010 interview, he said something that rarely gets quoted in popular accounts of his work. He said the most important thing CT has taught us is not about aliens, it is about us, about how rare our situation might be, and about what that rarity obligates us to do with it. Drake's equation was written as a tool for estimating the number of detectable civilizations. By the end of his career, he increasingly treated it as a tool for estimating the stakes of our own survival. Every parameter that goes into the equation is also a parameter that describes something about the conditions under which civilizations persist or fail. The equation is not just a census tool, it is a mirror, and the silence that fills in the right-hand side when you try to solve it is a mirror that reflects something specific back at us. Before we can understand what the silence means, we have to understand what it would take to break it. There is one more thing worth establishing before we move on. The Fermi paradox is sometimes discussed as though it simply needs more time, more telescopes, more data, more patience. The implication is that the silence is temporary and the answer will arrive eventually the way most scientific answers do, slowly, through accumulating evidence. That framing is not quite right. The Fermi paradox is unusual because the absence of data is itself the data. Every additional year the silence holds, every additional star surveyed without a confirmed signal, the problem sharpens rather than softens. The gap between what the scale of the universe predicts and what observation delivers does not stay the same size as the search expands. It grows. A problem that grows with better data is not a problem that patience alone resolves. This is why astronomers who have spent careers on the question tend to treat it not as an open problem pending a solution, but as a constraint already imposed on our understanding of the cosmos. The null result of 65 years of listening is not the beginning of the search, it is a result, and results have implications. A 72-second signal in 1977 is the best candidate humanity has ever found. That fact has not improved. In 1959, two physicists named Philip Morrison and Giuseppe Cocconi published a paper in Nature with a deceptively simple argument. Any civilization that understood chemistry would know that neutral hydrogen, the most abundant element in the universe, radiates at 1420 MHz when an electron transitions between energy states. Any civilization that wanted to be found would broadcast there. It is the one frequency that physics itself has written into the structure of matter as a meeting point. Morrison and Cocconi called it the cosmic watering hole. Within a year, Frank Drake had pointed a telescope at 2 nearby stars and listened at that frequency for 150 hours. He heard nothing. The project was called OSMA. It was 1960. The tools we have now are not comparable to OSMA. The Breakthrough Listen program, announced in 2016 with $100 million in funding, has access to the Green Bank Telescope in West Virginia and the Parkes Observatory in Australia. It has surveyed more than 1 million nearby stars across the full radio spectrum and looked at the 100 nearest galaxies for signatures of large-scale civilization. Its instruments can detect a signal equivalent to the total radio output of humanity aimed at us from 1,000 light-years away. The data is publicly available. Independent researchers have checked it. The scale of what has been searched deserves a moment of precision before we move on. Imagine the star nearest to our own, Proxima Centauri at 4.2 light-years, as a lamp sitting on a table across a room. On that scale, the nearest galaxy, Andromeda, would be roughly 4 kilometers away. The full volume of Space Breakthrough Listen has searched at its highest sensitivity a sphere of roughly 1,000 light-years in radius. Would on that scale be a sphere about 1 kilometer in radius centered on the lamp? That is not a small search volume in human terms. It is an extraordinarily small fraction of the galaxy. The Milky Way is 100,000 light-years across. Breakthrough Listen has searched, at its highest sensitivity, roughly 1% of the galaxy's diameter and a correspondingly smaller fraction of its total volume. This is a real limitation. Acknowledging it honestly is what science requires, but it does not change the null result within the searched volume. Within 1,000 light-year radius, with instruments sensitive to a signal no more powerful than our own current broadcasting technology aimed at us, the result is 0. And at the scale of full galaxy and multi-galaxy surveys looking for Type 2 and Type 3 signatures, the search volume is effectively complete. We should see galaxy-scale civilizations from anywhere in the observable universe with current infrared telescopes. We see none. The result is the same. Nothing that withstands scrutiny. Not ambiguous, not partially explained. Nothing. Against that backdrop, what the WOW signal represents is worth sitting with precisely. On the night of August 15th, 1977, the Big Ear Radio Telescope at Ohio State University was running a sky survey. Jerry Eman, a volunteer researcher, was reviewing the printout days later when he found it. A narrow-band signal at exactly 1,420 megahertz, the hydrogen frequency, coming from the direction of Sagittarius. It was 30 times stronger than the background noise. It had the exact shape a signal from space would have, as the Earth rotated the telescope beam through the source. It lasted 72 seconds, the precise duration the telescope would take to sweep through a fixed point in the sky. Eman circled it in red pen and wrote one word in the margin. Wow! The signal was never detected again. Not for lack of trying. Big Ear returned to those coordinates hundreds of times. When Big Ear was demolished in 1997, other facilities took over. The Allen Telescope Array has visited those coordinates. Breakthrough Listen has visited them. No repetition, no trace, no confirmation. Here is the duration inversion that makes 72 seconds in 65 years of listening land properly. The SR-71 Blackbird, the fastest air-breathing aircraft ever built, could cross the continental United States in 68 minutes. Our 65-year listening window, converted to the same scale, represents not a brief survey, but roughly 570,000 hours of accumulated observation time across multiple telescopes. In those 570,000 hours of listening, aimed at the most promising frequency, with instruments sensitive enough to detect a civilization broadcasting at our own level from 1,000 light-years away, the total positive evidence is one 72-second signal that never repeated. That is not a gap in our coverage. That is the coverage itself returning an answer. Now consider what a Kardashev Type 2 civilization, one that has harnessed the full energy output of its star, would look like to us. The Sun outputs roughly 4 times 10 to the 26th watts. A civilization that has captured even a fraction of that for electromagnetic broadcasting would produce a signal detectable from thousands of light years away, with instruments no more sophisticated than the ones we currently have. A Type 3 civilization galaxy scale would produce infrared waste heat signatures detectable from anywhere in the observable universe. Jason Wright at Penn State led a systematic search of 100,000 galaxies for exactly those signatures. He found no strong candidates. Consider first what a Type 1 civilization looks like electromagnetically. Earth, a Type 1 candidate in progress, produces roughly 2 times 10 to the 13th watts of total power consumption. Our radio emissions are far weaker in total because most of our energy is not put into electromagnetic broadcasting. But the leakage, the incidental radiation from radar installations, broadcast towers, satellite uplinks, is enough to produce the electromagnetic anomaly that a sufficiently sensitive external observer could detect. We are electromagnetically present, even though we are not broadcasting intentionally. Now scale upward. A Type 2 civilization controls roughly 4 times 10 to the 26th watts, the full output of its star. Even if it is electromagnetically disciplined, using that energy efficiently with minimal leakage, the engineering required to capture stellar energy produces detectable waste heat. The second law of thermodynamics is not optional. Energy used for any purpose must be eventually dissipated as heat, and a structure large enough to capture stellar energy produces an infrared signature visible across thousands of light years. We have looked for those signatures. The surveys have been systematic, using multiple infrared telescopes across multiple wave bands toward individual nearby stars and toward entire galaxies. The result in every case is the same. The anomalous infrared signatures found resolve, under more careful examination, into natural explanations. Dust disks, asymmetric stellar envelopes, unusual stellar evolution stages, nothing artificial. The sky, at the level of sensitivity these surveys achieve, is clean of Type 2 signatures. It is clean of Type 3 signatures. It is, as far as our instruments can determine, clean of everything above us on the Kardashev scale. The silence is not a technology problem. The tools are adequate. The silence is the signal, which means the real question is not whether we are looking correctly. It is why, given that we are looking correctly, the answer keeps coming back as nothing. And the explanations serious researchers have proposed for that nothing are, without exception, more unsettling than the question. There is one calibration check worth performing before moving on. We know our instruments are sensitive enough to detect us. In a 1974 experiment now called the Arecibo message, the Arecibo radio telescope transmitted a narrow radio signal toward the globular cluster M13, 25,000 light-years away, lasting 169 seconds. The message, designed by Frank Drake and Carl Sagan, encoded a pixelated image containing information about humans, DNA, and Earth's position. A telescope with the sensitivity of Arecibo could have detected that signal from M13 if M13 contained a receiving antenna of comparable size. We have instruments capable of detecting our own broadcasts at 25,000 light-years. We have found nothing from the direction of any star at any distance. The Breakthrough Listen program's published sensitivity limits make this more concrete. For nearby stars within 100 light-years, Breakthrough Listen could detect a transmitter producing roughly 10 megawatts of radio power in a directional beam aimed at Earth. That is less power than a large AM radio station uses for non-directional broadcasting. A civilization at our level of technology deliberately trying to signal us from within 100 light years, would be detectable with current instruments. We have found nothing within 100 light years, nothing within 1,000 light years at higher power levels, nothing at galactic scale at the power levels a Type 3 civilization would produce passively. The calibration confirms the instruments, the absence confirms the absence. There is one more layer to the detection picture worth establishing before the explanations. We are not only listening for deliberate signals, we are also listening for incidental ones. The electromagnetic leakage from a century of our own technology has created an expanding sphere of radio noise, roughly 200 light-years in diameter. Any civilization within that sphere with instruments comparable to what we are currently building would detect us. Not because we're trying to be found, because civilization leaks. A civilization that achieved radio technology 1 million years ago would have produced a leakage sphere 2 million light-years across. The wavefront of their incidental broadcasting would have reached us. It has not. Either such civilizations do not exist at any significant frequency, or they stopped leaking, or they never started. All three options have implications that the casual framing of the Fermi question tends to skip over. The silence is not just an absence of deliberate contact attempts, it is an absence of noise, and the noise of civilization is not something you switch off easily once you have started producing it. Every answer to the Fermi paradox makes the universe worse than the question did. Run the false hope ladder. Each rung looks like a way out. Each rung collapses. First rung. Maybe they have not had enough time. Maybe the galaxy is young enough in the relevant sense that complex life has only recently become possible, and we are among the first generation of technological species. The early universe was hostile. Short-lived massive stars exploded frequently, irradiating their stellar neighborhoods with lethal radiation. The galactic environment only became hospitable for long-lived planetary systems in the last few billion years. We might be early. Collapse. The hospitable era has been running for several billion years. There is nothing uniquely favourable about Earth's position, or its sun, that would not also apply to thousands of other star systems in similar galactic environments that formed billions of years earlier. If life can arise here under these conditions, it could have arisen elsewhere under these conditions long before us. The time argument weakens the problem by a factor. It does not close the gap. Second rung. Maybe they are there but too far away. A civilization 50,000 light-years away sent signals that are still in transit. We have not heard them because the speed of light imposes a delay we have not yet waited out. Collapse. A civilization does not need to send signals. It needs to expand. Physical colonization at 1% of the speed of light fills the entire Milky Way in 10 million years. A civilization that arose 500 million years before us and expanded at that modest rate would have reached every star system in the galaxy 50 times before we evolved. Physical traces, megastructures, industrial signatures, deliberate markers would be observable. We observe none. Third rung. Maybe we are not listening on the right frequency or with the right technology. Maybe advanced civilizations use quantum entanglement networks, or neutrino beams or communication methods we have not yet conceived of. Collapse. The argument is philosophically honest but practically unfalsifiable, which makes it useless as an explanation. More critically, any civilization sophisticated enough to develop exotic communication methods is also sophisticated enough to understand that a newly emergent technological species would be using electromagnetic radiation. If they wanted to make first contact with a civilization at our stage, they would use our methods. The fact that nothing has used electromagnetic signals aimed at us, despite 65 years of listening, does not become less significant because we invent the possibility of methods we cannot detect. Fourth rung. Maybe they exist but have no interest in contacting us. A sufficiently advanced civilization might regard us the way we regard an ant colony, present, alive, but not worth the effort of communication. Collapse. Disinterest does not explain the absence of passive signatures. A civilization does not have to be trying to contact us to be detectable. Its industrial activities, its energy consumption, its electromagnetic leakage would all leave traces visible across stellar distances. Disinterest does not make a Dyson sphere invisible. It does not remove the infrared excess. It does not quieten the waste heat. Disinterest and invisibility are not the same thing. The ladder has 4 rungs. All 4 collapse. What remains is not a comfortable explanation. What remains is the compounding barrier stack, and the stack is where the argument goes from unsettling to genuinely dark. The compounding barrier stack, applied precisely to our situation, runs as follows. Signal degradation by the inverse square law means radio power falls as the square of distance, reducing a powerful transmission to undetectable noise over stellar distances unless it is aimed directly at us with enormous power. Temporal overlap requires 2 civilizations to exist in a detectable form, simultaneously across 13.6 billion years of galactic time. Frequency alignment requires broadcasting and listening on the same channel from an effectively infinite option space. Technological going dark means that advanced civilizations may become electromagnetically quieter as they develop more efficient energy systems, exactly as we would expect a mature civilization to do. Directional alignment means a targeted beam must point at us specifically during the narrow window we exist, with no knowledge that we are here. Each barrier is independent. Each is, on its own, a plausible explanation for the silence. Together, they multiply. The probability of any given civilization both producing a detectable signal and having it intercepted by us at this moment in history is the product of all 5 probabilities, not the sum. And that product, even with generous estimates for each individual probability, becomes vanishingly small. But here is the problem with the stack as a complete explanation. It does not account for civilizations that have had millions of years to work around every barrier on the list. A civilization a million years ahead of us technologically could, if it wanted to be found, build something that none of these barriers could stop. Beacons designed to be found. Megastructures that announce themselves by the physics of their operation. Signs that require no intent to signal because they are the automatic consequence of operating at civilizational scale. We see none of those either. The stack explains why contact is hard. It does not explain why the sky is this clean. A 2018 paper by Anders Sandberg, Eric Drexler, and Toby Ord at Oxford's Future of Humanity Institute made the statistical case precisely. Using Bayesian reasoning across the full uncertainty range of the Drake equation parameters, they showed that the silence is compatible with several radically different underlying realities, ranging from we are effectively alone in the observable universe to there are many civilizations but almost none are detectable with our methods. What the paper clarified is that the silence does not resolve the question. It constrains the answers, and the answers it is compatible with include some that are deeply frightening. There is one more rung on the ladder that gets raised often enough to deserve a direct response. Maybe they are deliberately leaving us alone. Maybe there is a galactic civilization that has agreed to let developing species mature without interference, the way nature reserves function on Earth. This is sometimes called the zoo hypothesis. It collapses for the same reason the disinterest argument collapses. Deliberate non-interference does not make a civilization electromagnetically invisible. It does not remove the infrared signature of a Dyson sphere or the waste heat of galaxy-scale industry. If there is a consensus among advanced civilizations to leave us alone, that consensus would have to include an agreement never to perform any large-scale engineering anywhere in the observable universe in a way that might be detectable to developing species. The practical difficulty of coordinating that across the full volume of the galaxy, across the billions of years before we arrived, makes the zoo hypothesis unfalsifiable in a way that makes it unscientific rather than reassuring. The ladder has 5 rungs now, all 5 collapse. What the collapsed ladder leaves behind is not ambiguity. It is the compounding barrier stack and the 2 explanations that cannot be dismissed. The filter is behind us, or the filter is ahead. The compounding barrier stack that remains after the ladder collapses is not an explanation of the silence. It is a description of why contact is hard, which is a different thing. The stack explains why even if civilizations exist, we might not have heard from them yet. It does not explain why civilizations at the scale of Dyson spheres or galaxy-spanning infrastructure have left no passive signatures. Those signatures do not require contact. They do not require intent. They are the automatic byproduct of operating at that energy scale in a universe that runs on conservation laws. If Type 2 and Type 3 civilizations are common, they are visible regardless of whether they want to be. The absence of those signatures is not explained by any rung of the ladder, however carefully maintained. What remains is the 2 possibility space. Either the filters behind us were hard enough to make detectable civilizations genuinely rare, possibly rare enough to account for the absence of even incidental signatures across the observable universe. Or the filters are ahead of us, operating at the stage we currently occupy, and the signature of their operation is the silence we are observing. The second possibility is the one the next several sections address, because it is the one that connects the silence to us directly. The filter is real. The only question is whether we have passed it, or whether it is waiting. Robin Hanson, an economist and researcher at George Mason University, formalized the argument in 1998. The paper was short, the logic was not. If the universe produces technological civilizations at any reasonable rate, and none of them are detectable, then the chain of steps from chemistry to civilization contains at least one step that is extraordinarily improbable. Vanishingly rare. The kind of rare that happens once or twice in the entire history of a galaxy, if that. He called it the Great Filter. The chain runs roughly as follows: from simple chemistry to self-replicating molecules, from those to single-celled life, from prokaryotic cells to cells with a nucleus, from single cells to multicellular organisms, from multicellular life to complex animals, from complex animals to intelligence, from intelligence to radiotechnology, from radiotechnology to interstellar presence. Each step had to happen. Each step did happen here. The question is which of them is so improbable that it constitutes the step almost nothing gets past. Here is the concrete proof that focuses the question. On Earth, life appeared within a few 100 million years of the planet becoming chemically stable enough to support it. The Earth is 4.5 billion years old. The earliest chemical signatures consistent with biological activity date to around 4.1 billion years ago. Life got started fast. That speed is now broadly accepted by astrobiologists as evidence that the origin of life, the transition from chemistry to self-replication, is not particularly improbable. Given the right conditions, it happens readily. That is either a relief or a warning. If the origin of life is easy, the filter is not there. The filter is somewhere further along the chain, and every filter candidate you remove from the early part of the chain is a filter candidate you push into our future. The eukaryotic cell took 1.5 billion years to appear after the first bacteria, 1.5 billion years. For comparison, complex animals have only existed for 540 million years. The eukaryotic transition, The event in which a bacterium was absorbed by another cell and became the mitochondrion happened exactly once in the history of life on Earth. Every plant, every animal, every fungus descends from that single merger event. The biologist Lynn Margulis spent decades arguing for this model before the genetic evidence made it undeniable. One merger in 4 billion years of trying. That is a filter candidate. Intelligence is an even sharper data point. Complex animal life has existed for 540 million years. In that time, millions of species arose, diversified, and went extinct. Nervous systems became more elaborate. Brains developed. Problem-solving behavior appeared in dozens of lineages. Crows solve multi-step puzzles. Octopuses demonstrate planning. Dolphins develop individual names. Great apes use tools. And in exactly one of those millions of lineages did something emerge that built a radio telescope. One. In 540 million years of complex animal life. On a planet that was actively running the experiment of evolution across millions of simultaneously competing lineages. Intelligence as we possess it. The specific combination of bipedalism, language, abstract reasoning, cumulative culture, and technological capacity that leads to civilizations, appeared once. The evolutionary biologist Ernst Mayr made this point in direct debate with Carl Sagan in 1995. Mayr argued that high intelligence is not a direction evolution tends toward. It is a contingent outcome of a specific set of pressures that happen to converge in one lineage, at one time, on one planet. Bacteria have been the dominant life form on Earth for 3.5 billion years and show no signs of moving toward radio astronomy. Success in evolutionary terms does not require intelligence. Only one thing required it: us. Now the position that matters for the filter argument becomes clear. If the hard steps are all behind us, if the eukaryotic transition was the filter, or if intelligence was the filter, then the silence is explained. We are the 1 in a billion outcome of a process that almost always stops short. The road ahead is open. If none of those steps was the filter, if life, eukaryotes, and intelligence are all more common than the data suggests, then the filter sits somewhere else. And the only somewhere else available, given that we have crossed all the steps behind us, is somewhere in front of us. In 2018, the astrobiologist Nick Bostrom at Oxford made an argument that sounds counterintuitive until you follow it. He argued that discovering microbial life on Mars would be bad news for humanity, not because Martian microbes would be dangerous, but because finding them would confirm that the origin of life is common, removing it as a filter candidate. Every easy step we confirm behind us pushes the filter toward us. A universe where life starts readily, but technological civilizations are absent, is a universe where the filter operates late. And we are the thing that has not yet crossed it. Sit with the shape of that. You do not need to resolve it tonight. For now, just hold the structure. One filter, somewhere in the chain, that almost nothing crosses. We do not yet know which side of it we are on. The paleontologist Stephen Jay Gould spent much of his career arguing against the idea that evolution has a direction, a tendency toward complexity or intelligence or anything in particular. His argument was that life's diversity is a random walk from a simple starting point, constrained only by the wall of minimum complexity on one side and otherwise free to explore in any direction. Intelligence, on his account, is not the destination of evolution. It is one occupant of one particular region of a vast possibility space. The astrobiologist David Grinspoon at the Planetary Science Institute has framed the choice between filter behind and filter ahead in terms of what he calls the cosmic maturity test. Civilizations that survive long enough to become detectable across stellar distances have, by definition, passed through the technological bottleneck. They have managed nuclear weapons without destroying themselves. They have managed environmental disruption without collapsing their biosphere. They have developed artificial intelligence or equivalent capabilities without losing control of them. Whatever the specific tests are, passing them is what makes L large enough to matter in the Drake equation. Greenspan argues that the question of whether we pass the cosmic maturity test is not primarily a question about physics or engineering. It is a question about governance, ethics, and the ability to develop collective wisdom fast enough to keep pace with collective capability. We have never before in our history needed global coordination on problems that unfold on timescales shorter than political cycles. We need it now on several problems simultaneously. Whether that kind of coordination is achievable is, he argues, the central empirical question of the 21st century. The Fermi paradox provides the stakes. If Gould was right, and the fossil record provides considerable support for him, then the appearance of intelligence in exactly one lineage after 540 million years of complex animal life is not surprising. It is exactly what you would expect from a random walk that almost never produces any given specific outcome. Intelligence is not where evolution reliably goes. It is where evolution went once, here, under conditions that have not clearly been reproduced anywhere in the observable universe. There is a related point about the specific path to intelligence that the fossil record makes visible. The lineage that produced us, the hominins, branched from other great apes roughly 7 million years ago. In those 7 million years, multiple hominin species arose and went extinct. Homo habilis, Homo erectus, Homo heidelbergensis, Homo neanderthalensis, Homo denisova. At various points in the last 500,000 years, multiple hominin species coexisted on the same planet with comparable brain sizes. None of the others produced a civilization capable of radio astronomy. What distinguishes Homo sapiens from those cousins is not simply brain size. It is the specific cognitive architecture that enables cumulative culture, the ability to learn from others, modify what you have learned, transmit the modification, and build on it across generations until the accumulated knowledge exceeds what any individual could hold or generate. That architecture appears to be rare even among species that got close. Neanderthals made tools, they produced pigmented art, they may have had language. They did not produce radio telescopes in 300,000 years of existence. Whatever it is that we have that they lacked, it is not obvious what it is, and the fossil record suggests it is not something that arises automatically from large brain size. That specificity is itself a filter candidate. Not just intelligence, not just language, not just tool use. The exact combination that leads from scattered hunter-gatherers to global civilization in 10,000 years. Whatever that combination is, it appeared once in the history of life on Earth. That once is consistent with it being extraordinarily rare in the history of life on any planet. There is an additional consideration from the fossil record that makes the intelligence singularity even more specific. The transition from Homo habilis, who made simple stone tools around 2.5 million years ago, to Homo sapiens with cumulative culture and symbolic art, took roughly 2 million years of hominin evolution. During that period, brain size roughly tripled. But brain size alone does not produce civilization. Neanderthals had brains as large as ours or larger by volume, and coexisted with Homo sapiens for tens of thousands of years without developing writing, agriculture, or radio technology. Whatever the specific cognitive innovation was that distinguishes our lineage from all others, it is not yet precisely identified. Candidates include the capacity for fully recursive language, the ability to attribute mental states to others with the precision required for complex social coordination, a specific improvement in working memory that allows holding multiple abstract concepts simultaneously, or some combination. The innovation was specific. It appeared late in hominin evolution, and it appeared in exactly one lineage out of the dozens of hominid and hominin species that evolutionary history produced. That pattern is the signature of an improbable event rather than a probable convergent outcome. If the cognitive innovation that produces civilization is as specific as the fossil record suggests, the probability of it arising independently on another planet, even one with a long history of complex animal life, may be low enough to account for the silence without any filter ahead of us at all. That low probability, combined with the null result, produces the most internally consistent explanation available. We are the rare exception that the math allows but does not require. That reading of the fossil record, combined with the null result of 65 years of CT, produces the most consistent explanation for the Fermi silence available. We're genuinely rare, the hard steps are genuinely behind us, and the road ahead is open in a way it was not before we cleared those steps. The alternative, that the steps behind us were easy, and the silence is explained by a filter still ahead, is not ruled out. But it requires the silence to be hiding something that the rare Earth hypothesis does not. In a universe where every civilization knows the others exist, silence is not peace, it is strategy. This explanation for the silence requires no filter at all. It requires only two premises and a mind willing to follow them where they go. Premise 1. Resources in the universe are finite. Stars burn out. Energy is conserved. Any sufficiently old civilization understands that it competes with every other civilization for the same finite pool of usable energy. Premise 2. You cannot know another civilization's intentions. This second premise is deeper than it appears. Your brain treats the word closest as meaningful, because closest water source determined whether your tribe survived or died. That cognitive shortcut served our species for 300,000 years on a planet 8,000 miles across. It does not transfer to a galaxy 100,000 light-years wide, populated by minds that evolved under conditions utterly unlike ours, over timescales utterly unlike ours, with values and drives we have no basis for predicting. You detect a signal. You know something intelligent is there. You know nothing else. Now you have a choice. Respond, revealing your location, or stay silent. If you respond, and the other civilization is cooperative, potential contact. If you respond, and it is competitive, you may have ended your civilization. If you stay silent, you lose the contact but retain your existence. The asymmetry is total. The cost of being wrong about a cooperative civilization is a missed connection. The cost of being wrong about a competitive one is extinction. Under genuine uncertainty with that penalty structure, the rational strategy is silence. Not because the others are necessarily hostile, because you cannot rule out that they might be, and the penalty for misjudging is absolute and irreversible. Game theorist Martin Nowak's decades of work on the evolution of cooperation show that cooperation emerges and persists when agents interact repeatedly, can recognize each other, and when cooperation's benefits outweigh defection over time. Interstellar distances remove every condition. You cannot interact repeatedly across thousands of light years. You cannot recognize. The timescales of any exchange span civilizational lifetimes. Under those conditions, what Nowak's models consistently produce is exactly what the dark forest hypothesis proposes. Default to caution, reveal nothing, survive. In 2015, a group of researchers and public figures, including Stephen Hawking, signed an open statement calling for a moratorium on active SETI, the deliberate broadcasting of messages toward other stars. Hawking's argument was explicit. History shows what happens when a technologically superior civilization encounters one that is not. The statement was disputed. Others argued we'd been broadcasting involuntarily for a century through radar and television leakage, and that the concern was therefore belated. but the debate reveals something important. The people who take the Fermi paradox most seriously are not uniformly comfortable with the idea that being detected is desirable. Now apply the dark forest logic to the wow signal. A 72-second narrowband signal at the hydrogen frequency from a fixed point in Sagittarius, never repeated. The standard interpretation is that non-repetition suggests it was not artificial, because a civilization trying to make contact would broadcast continuously or repeatedly. But a civilization operating under dark forest logic would not broadcast continuously. It would send a single pulse, confirm the target received it, and go dark. A repeated signal is a locatable signal. You do not knock twice when the cost of being found is potentially everything. The dark forest does not tell us the wow signal was real, but it tells us our standard evidentiary tools for evaluating anomalous signals were built on an assumption that contact is sought rather than avoided, that may not hold for every type of intelligence we might encounter. If even a fraction of civilizations reason this way, the galaxy goes dark, not because civilizations failed, because they survived long enough to understand why broadcasting is dangerous. The silence is not evidence of absence, it is evidence of caution. And if they are watching, they already know we are here. We have been leaking our position for a century. There is a version of the dark forest logic that is even more unsettling than the basic formulation. It does not require any civilization to be hostile. It requires only that civilizations be uncertain, and that uncertainty in the presence of the asymmetric penalty structure produces the same outcome as hostility. Consider what it means for a civilization 1,000,000 years more advanced than us to receive our electromagnetic leakage. They cannot know our intentions. They cannot know our capabilities relative to theirs 1,000,000 years from now. They cannot know whether we will become a threat. From their perspective, we are a new variable in a universe where new variables carry risk. The rational response to an unknown variable in a high-stakes environment is not engagement. It is monitoring at a distance while revealing nothing. The symmetry that Scripsix identified is the most philosophically precise version of this. Whatever loneliness we feel gazing outward, they feel in equal measure gazing back, if they are there at all. Two civilizations, each aware of the other's existence, each unable to cross the distance, each constrained by the same physics, each uncertain of the other's intentions, each choosing silence as the survival strategy. Both of them calling the other the closest. Both of them wrong about what that word means at this scale. Both of them too far away to ever resolve the uncertainty. The compounding barrier stack from Script 6 applies to the dark forest scenario with particular force. If you add directional alignment, temporal overlap, and technological going dark to the basic game theory argument, the probability that any two civilizations manage to establish a stable, cooperative, ongoing relationship across interstellar distances approaches zero, even without any hostile intent on either side. The physics conspires with the game theory. Distance means any exchange takes centuries at minimum. Anything that takes centuries cannot be negotiated in real time. Anything that cannot be negotiated in real time cannot build the kind of mutual trust that cooperation requires. The universe is structured in a very specific and physical sense, against the kind of relationship that would make the dark forest dynamic unnecessary. Two civilizations cannot have a conversation. They can only exchange statements separated by centuries, with no ability to respond to the other party's response until both of them may have changed beyond recognition. Script 6 from the competitor database identified the word closest as the cognitive trap at the center of this argument. The brain treats closest as meaningful because closest water source determined whether your tribe lived or died 300,000 years ago on the African savanna. Nearest predator. Nearest shelter. Nearest food? Closest is a survival concept built into the architecture of human cognition by millions of years of selection pressure. In space, closest means only the smallest entry in a table of distances that are all, without exception, too large for any of the cognitive shortcuts built around that word to apply. The nearest civilization, if one exists, is not close in any sense that the word close was built to describe. It is, at minimum, years of travel time at the speed of light, and more likely decades or centuries. The cognitive shortcut that makes nearest feel like reachable is the shortcut that produces the intuition that contact with another civilization is plausible within a human time frame. That intuition is what makes the Fermi paradox feel solvable. The physics is what makes it not. In that context, silence is not paranoia. Silence is the physically determined equilibrium of a system where the cost of being wrong is absolute, and the mechanism for building the trust that would make the risk acceptable is foreclosed by the speed of light. Every civilization that reaches radio technology also reaches the ability to end itself. We are the proof. Carl Sagan made this argument in The Cosmic Connection in 1973, and he made it as a physicist, not a moralist. The nuclear weapon and the radio telescope are products of the same physics, the same understanding of electromagnetism, thermodynamics, and atomic structure that produces one produces the capability for the other. You cannot have a civilization sophisticated enough for radio astronomy without that civilization simultaneously possessing the tools for its own elimination. This is what makes the L term in the Drake equation so critical. L is not set by stellar physics or geological time, it is set by whether a civilization survives its own adolescence. And the evidence from our own history suggests that adolescence is a period of acute danger. Consider the compressed window. Homo sapiens evolved roughly 300,000 years ago. Agriculture arrived about 10,000 years ago, writing 5,000 years ago. The splitting of the atom 1945, the sequencing of the human genome 2003, the development of artificial systems with capabilities that compound faster than the institutions designed to govern them, present. From stone tools to nuclear weapons took less than 10,000 years. On a galactic timescale, that interval is not a period of time, it is a singularity, a flash, and within that flash, we acquired the ability to end ourselves multiple times over. There is no pulling over. There is no external governing body. The ship may fly. The engines may burn. The civilization still ends if it fails to manage what it has built. The physicist Freeman Dyson noted that the time between a civilization developing nuclear technology and either destroying itself or learning to manage it is, in astronomical terms, very short. Perhaps centuries, perhaps a few thousand years. On a 13 billion year timescale, a civilization that lasts 500 years is indistinguishable from one that never existed. It appears as a brief electromagnetic flicker, lasts for a moment, and goes silent. This is what the L term means in practice. We have been broadcasting electromagnetic signals at detectable levels for roughly 100 years. Our signals have reached a sphere of space about 100 light-years in radius, which sounds large until you note that the Milky Way is 100,000 light-years across. Our footprint is 1/1,000,000th of the galaxy's volume, and it has only existed for a century. If we stop tomorrow, by catastrophe or by choice, our electromagnetic signature would propagate outward for a century more and then fade below detectability. A civilization 200 light-years away, looking at us in the year 2200 with instruments like ours, might catch the edge of our wavefront and find nothing behind it. We would look like a flicker, a source that appeared briefly and went silent. This is what the galaxy looks like if the filter is ahead, not empty, full of flickers, each one a civilization that reached our stage, each one that failed to cross the threshold between technological adolescence and something more durable. The flickers go silent, the light propagates outward, and from any distance the galaxy appears exactly as it appears to us, quiet. If we are inside this filter, and we do not yet know that we are not, then what we are living through right now is the interval that determines which category we fall into. Not in an abstract sense, in the precise sense that every civilization currently at our stage either navigates the next few centuries or does not, and the distribution of outcomes is what the silence is reporting. This is the moment to subscribe if you have not already. Not because the argument is finished, because the next section is the one that requires you to sit still for a moment before we go further. The specific risks we currently face have a structural feature that makes them different from every previous risk in human history. They compound faster than our institutions were designed to manage. The development of agriculture created new food security risks that took thousands of years to produce governance structures capable of managing them. The development of industrial chemistry created environmental risks that took a century to produce regulatory frameworks. The development of nuclear weapons created existential risks that produced arms control frameworks within decades, though whether those frameworks are adequate remains an open question. The acceleration is the problem. Each new capability arrives faster than the previous one, and each new risk it creates requires more coordination, more institutional wisdom, more global alignment to manage. The timeline from radio astronomy to the ability to engineer pathogens to the development of powerful artificial systems has compressed to within a single human lifetime. The institutional wisdom required to manage each of those capabilities is not compressed proportionally. The gap between what we can do and what we know how to govern is, by most honest assessments, widening. This is what makes the L term in the Drake equation so specifically frightening when read in the context of the silence. L is not asking whether civilizations destroy themselves. It is asking whether civilizations manage to keep L long enough to become the kind of civilization that shows up in the survey data. A civilization with L equal to 300 years is electromagnetically invisible from beyond 300 light years. At any given moment, the number of civilizations with L greater than 300 years that are also within 300 light years of Earth is, if L is typically small, consistent with zero. The silence is consistent with zero. There is an additional detail in the self-destruction argument that rarely gets mentioned. It concerns not the endpoint but the transition itself. A civilization that successfully crosses the technological bottleneck does not necessarily become electromagnetically louder. It is at least as likely to become quieter. Advanced energy systems, if efficiently designed, leak less. Advanced communication systems, if sufficiently sophisticated, are likely to use narrowly directed beams rather than omnidirectional broadcasting. A mature technological civilization may become electromagnetically quieter than it was at our stage, not because it has gone dark in the dark forest sense, but because efficient technology simply does not waste energy in all directions. This means the silence is compatible with successful civilizations as well as with failed ones. A universe full of mature, stable, electromagnetically quiet civilizations would look, to an observer at our stage, indistinguishable from a universe where civilizations consistently fail. We cannot, from the outside, distinguish between the two. The silence is the silence either way. What we can do is notice that we are currently at the stage where the distinction matters most to us directly, and that the evidence is consistent with both readings without resolving either one. Take a breath here. Everything covered so far is grounded in physics, in evolutionary biology, in game theory, and in the public record of the search as it has actually been conducted. None of it is speculation. All of it converges on the same thing. The silence does not prove we are alone. It proves something ends civilizations. We are the next candidate. The universe is 13.8 billion years old. It contains an estimated 2 trillion galaxies, each with hundreds of billions of stars. By the most conservative chemistry, there are more potentially habitable planets in the observable universe than there are grains of sand on every beach on Earth. Life, according to everything we know about its origin on this planet, is not particularly hard to start. And yet 65 years of the most sensitive listening ever conducted, on the most plausible frequency, with instruments capable of detecting a civilization broadcasting at our level from 1,000 light-years away, has returned nothing confirmed. The gap between what the scale of the universe predicts and what the instruments find is not a small discrepancy. Every year the search expands, every additional star surveyed, every additional galaxy scanned. The null result gets more precisely null. The silence is not fading into noise, it is holding, it is being confirmed by better data. Carl Sagan, in 1994, looking at a photograph taken by Voyager 1 from 3.7 billion miles away, described Earth as a pale blue dot, a fraction of a pixel against the black. He said, "Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves." That sentence is a precise summary of what the Fermi paradox confirms. Not that we are unimportant, that the help we might have imagined arriving from elsewhere is not coming, because if it existed, the instruments would have found it. The signals would be there. They are not. Which means the responsibility for what happens next is entirely local. It rests with the one species on the one planet that is currently, as far as every instrument we have can determine, the only thing in this galaxy asking these questions. Whether that rarity is a sign that the hard steps are behind us, or a sign that they are ahead, we do not yet know. The silence says only that something is filtering, consistently enough to keep a 13.6 billion-year-old galaxy this quiet. There is a version of this moment that is worth sitting with explicitly, because it is easy to miss in the accumulation of data and argument. Right now, tonight, the most sensitive listening instruments humanity has ever built are pointed at the sky. They are processing data at rates no previous generation of astronomers had access to. They are achieving sensitivities that would have seemed impossible a generation ago, and they are returning silence. That silence is being produced in real time. It is not a historical fact about what other generations found. It is the present tense output of the best search we know how to conduct. Every hour that passes without a confirmed signal is another hour added to the 65-year total. Every star added to the survey is another data point. The silence is live, it is updating, and it keeps saying the same thing. What that ongoing silence means for you, sitting where you are right now, is that you are a member of the one species in this galaxy that is currently both asking the question and capable of doing something about the answer. That is not a small position to be in. It is, if the Fermi paradox is correctly understood, among the most consequential positions any mind has ever occupied. Rest there for a moment. The next section is where the silence stops being about them and starts being about us. The astronomer Carl Sagan returned to this question throughout his career, and each time he did, his framing became more precise. In his 1994 book Pale Blue Dot, he wrote that the Earth is a very small stage in a vast cosmic arena, that our posturings, our imagined self-importance, are challenged by this point of pale light. But he also made a specific claim about what the silence implies for responsibility, that there is no hint that help will come from elsewhere to save us from ourselves. The Fermi paradox, understood clearly, is the scientific evidence underlying that claim. It is not a philosophical observation about our small size. It is an observational constraint that, if the silence is correctly interpreted, means the cavalry is not coming, not because they do not exist, because if they exist at all, they are unreachable, and if they are unreachable, the problems we face are problems we face alone. That is not a counsel of despair. It is a description of the actual situation. The actual situation is that the species which has, in the last 100 years, developed the capacity to destroy its own civilization multiple times over, is operating without external oversight, without external assistance, and without precedent for what it means to navigate the transition from technological adolescence to something more durable. The silence says this is a transition almost nothing navigates successfully. Whether we are the exception depends on choices being made right now, by people alive right now, on a planet whose electromagnetic signature has been visible to any sufficiently sensitive observer for a century. There is no instruction manual. There is no older civilization that navigated this successfully and left notes. There is no signal in the sky saying, "Here is what worked for us. Here is what to avoid." The silence is the only communication we have received from the universe on this question. And the silence says, most do not make it. Whether that is a description of our probable future or a description of why we are rare enough to have reached this moment without a predecessor to learn from, is the question that the next few decades of our history will answer. That is the weight of the silence, not abstract, not philosophical, specific, immediate. Addressed to this generation, living in this window, making the decisions that the silence suggests are the hardest ones any civilization ever faces. If the filter is ahead, every year we survive past this moment is a year no one else has managed. Let us approach this from the direction of the evidence for the filter being behind us, because that evidence is real and it deserves to be stated plainly. Breakthrough. Listen has surveyed more than 1 million stars and has found nothing confirmed. The Jerry Harp survey at the SETI Institute used the Allen Telescope Array to search for megastructures and found none. The Roger Griffith analysis at Penn State examined 100,000 galaxies for the infrared waste heat signature of Type 3 civilizations and found no convincing candidates. Tabby's star, Cassini 842852, which became briefly famous in 2015 when its anomalous dimming pattern prompted speculation about megastructure construction, was examined by Breakthrough Listen at radio frequencies. Nothing was detected. Subsequent analysis showed the dimming is consistent with dust and in falling cometary material. Natural. The pattern is consistent. Anomaly. Scrutiny. Natural explanation. Every time. If you take that result at face value, civilizations capable of detectable large-scale signatures are extraordinarily rare. Rarer than one per galaxy, which means the filters behind us were genuinely hard. Which means what exists on this planet may have happened once in the entire history of this galaxy. The rare Earth hypothesis, developed by Peter Ward and Joe Brownlee in 2000, catalogued the conditions required for complex animal life, the right kind of galaxy, a stable spiral arm with low supernova rates, a single G-type star with low variability, a planet in the habitable zone, a large moon to stabilize axial tilt, a Jupiter-class planet to deflect cometary bombardment, plate tectonics to recycle carbon, a planetary magnetic field. Each condition met on Earth reduces the field of candidates when required simultaneously. Ward and Brownlee's conclusion was not that life is impossible elsewhere. It was that the specific combination required for complex animal life and the path to technology may be rare enough to make us nearly alone in this galaxy. If they are right, we are the anomaly. The experiment ran billions of times and produced us once. The silence is not a warning. It is a census result. But the burden that comes with that reading is not comfortable either. If we are rare, if we're possibly the only technological civilization in this galaxy, then what happens here matters in a way that is difficult to overstate. Every species that has gone extinct on this planet took something with it that will not return. Every language that has gone silent took a way of seeing the world that no longer exists anywhere. If we are the only thing in this galaxy that has ever looked at it and asked what it means, then what we do with the next few centuries is not just our problem. 65 years. That number opened this. It was at the start a duration, how long we have been listening. Now it carries different weight. It is a data point in the most consequential question the species has ever faced. Are we alone because the hard steps are behind us? Or are we alone because the hard steps are ahead, and the silence is how we know that other candidates have already run into them? The two answers demand different responses. The first demands that we protect what we are, because we are the exception. The second demands that we understand what we are doing, because we are about to become the next entry in the silence. Either way, the silence is not passive. It is instructive. It is pointing at something, and that something is us. The Fermi paradox began as a question about where everyone else is. Honestly followed, it becomes a question about where we're going. The philosopher Nick Bostrom, who first made the Mars argument precise, also made a related point about what the silence implies for our intuitions about the future. We have a tendency, he argues, to assume that if something has not killed us yet, it is unlikely to kill us. Civilizations that have survived this long must be doing something right. But the Fermi paradox undermines that intuition directly. The silence suggests that surviving to our current stage is not the hard part. The hard part, the part that almost nothing navigates successfully, may lie just ahead. Survivor bias operates powerfully here. Every civilization that reaches our stage believes it has already proven something about its viability, because it has survived long enough to ask the question. But the stage we are at is the stage that the Fermi paradox, if correctly interpreted, identifies as the bottleneck. The belief that we have demonstrated our viability by reaching this stage is precisely the belief that a civilization about to fail the filter would hold. It is not evidence of safety. It is evidence that we are in the place where the filter operates. That is not a reason for despair. It is a reason for precision. A civilization that understands it is in the filter zone, that identifies the specific risks the silence is pointing at, and that develops the institutional capacity to manage them, is exactly the kind of civilization that produces large L. The Fermi paradox, understood clearly, is not a death sentence, it is a diagnostic. The physicist and cosmologist Max Tegmark at MIT has argued that the development of artificial intelligence represents a potential filter candidate that operates on a much shorter timescale than any previous risk we have faced. Nuclear weapons took 7 years from the theoretical insight to the first functional device. The development of transformative artificial intelligence, once the necessary algorithmic and computational conditions are met, may take far less. The difference between nuclear weapons and advanced AI as filter candidates is the speed of the transition and the difficulty of the governance problem. Nuclear deterrence, whatever its risks, has a relatively simple game theory. Two parties, each with the capacity to destroy the other, each with an incentive to avoid mutual destruction. The governance of nuclear weapons has been imperfect, but it has been legible. The governance of advanced AI systems involves not two parties, but thousands of actors, operating under conditions of competitive pressure across a technology whose capabilities and risks are not yet fully characterized. The governance problem is harder, the timescale is shorter, and the filter, if it operates through this mechanism, would be invisible until it operated. This is speculative, and it should be labelled as such. No one knows whether AI development constitutes a filter candidate or whether the transition will be managed safely. What is not speculative is that we are the first generation of humans to face this specific question, at this specific scale, and that the silence suggests most civilizations at our stage did not navigate the equivalent question successfully. The researcher Toby Ord at Oxford's Future of Humanity Institute has spent years trying to estimate the probability that humanity survives the next century without catastrophic civilizational damage. His estimate, published in his 2020 book The Precipice, is that the probability of existential catastrophe in the next 100 years is roughly 1 in 6, the odds of a single pull of a trigger in Russian roulette. Other researchers put the number higher, some put it lower. The specific number is less important than the order of magnitude. We're not talking about a negligible risk. We're talking about a coin that may not land the way we assume it will. Now apply that to the Fermi paradox. If the probability of an individual civilization navigating its technological adolescence successfully is even 1 in 6, and civilizations reach technological adolescence at any reasonable rate across the galaxy, the number that successfully cross the threshold is a small fraction of the number that try. The galaxy populates with short-lived flickers. The spectrum stays clean. The silence is explained without requiring any dramatic filter in our evolutionary past. The silence, in other words, may not be telling us anything about the difficulty of producing intelligence. It may be telling us something about the difficulty of keeping it once you have it. That is the reading that makes the silence directly relevant to every decision made in the next century. Not as a philosophy thought experiment, as a calibration on the actual odds. The Pioneer plaque is still out there. We attached a return address to the first object we ever sent beyond our solar system, before we knew enough to be frightened of it. In March 1972, Pioneer 10 launched from Cape Canaveral. Its mission: survey Jupiter, then continue outward past the edge of the solar system and into interstellar space. Before it launched, Carl Sagan and Frank Drake were given 10 days to design something for its side, something permanent, something communicative. The Pioneer plaque is a gold anodized aluminium plate 6 by 9 inches. It shows a man and a woman in silhouette, the man's hand raised. Behind them is an outline of the spacecraft to give scale. In the upper left, a schematic of the hydrogen hyperfine transition, the 1 to 420 MHz frequency, serves as a universal unit of length and time. A starburst radiates from the Sun, pointing to 14 pulsars, each labelled with its pulse period in binary, so any finder can triangulate the source star. At the bottom, a diagram of the solar system shows a spacecraft leaving from the third planet. It contains, in the most compressed form achievable in 1972, everything a stranger would need to find us. Pioneer 10 is now more than 13 billion miles from Earth. It passed beyond the heliosphere, the bubble of solar wind that marks the edge of the Sun's direct influence, in the early 1980s. It moves at roughly 25,000 miles per hour. In approximately 2 million years, it will make a distant pass through a star system near Aldebaran. The plaque will still be there. The gold anodizing will be largely intact. On any human timescale, the Pioneer plaque is permanent. It will outlast every building on Earth, every language, every institution, every memory of every person who has ever lived. We chose to do this before the Fermi paradox had been formalized in its current form, before the active SETI debate had begun, before the dark forest logic had been articulated. Sagan and Drake chose to attach a return address to the first vehicle we ever sent beyond our system, because they believed the act of reaching out was worth doing regardless of who might answer. The Voyager Golden Records, launched in 1977, went further. 2 spacecraft, each carrying a gold-plated copper disc, 115 images of Earth and its life, greetings in 55 languages, 90 minutes of music from traditions across the world, the sound of surf, wind, thunder, animals, a heartbeat. Not just our position, but our character. Who we were when we made the choice to send it. Now sit with the irony the dark forest hypothesis makes visible. We have been broadcasting involuntarily for a century. Our television and radar signals have created an expanding electromagnetic sphere, roughly 200 light-years in diameter. We are not invisible. We have not been invisible since 1925. If any civilization within that radius has instruments comparable to the ones we are currently building, they know we are here. The Pioneer Plaque, the golden records, every television broadcast since the 1930s, the radar pulses bouncing off our atmosphere, all of it is already in transit. The choice of whether to signal has already been made. Whatever that means in the context of the silence, it cannot be undone. There is something almost clarifying about that. The decision was made before we knew enough to debate it seriously, by people who thought speaking into the darkness was worth doing. The Pioneer Plaque will outlast every argument we ever have about whether sending it was wise. That is the nature of signals. Once sent, they belong to the universe. There's something worth dwelling on in what Sagan and Drake chose to put on the Pioneer Plaque. They chose honesty over strategy. The plaque shows two human figures, anatomically accurate. It includes the schematic of hydrogen emission, the one language any physicist would share. It gives our position precisely enough that any civilization with our level of astronomy could find us. There was no calculation of how to appear least threatening. There was only the question of what would be most truthful. That choice, made before the active SETI debate had crystallized, before the dark forest logic had been formally articulated, reflects something about the culture that produced it. We made a message in the hope that it would be received in good faith, without knowing whether good faith was a reasonable expectation at interstellar scales. The Pioneer Plaque does not hedge. It says, "This is what we look like. This is where we are. This is when we were here. Find us if you can." The Voyager records extend this impulse further. 90 minutes of music from dozens of cultures, greetings in 55 languages, the sound of a mother speaking to a child, a heartbeat, rain, surf. Not just our position, but our interiority. What mattered to us. What we sounded like when we were alive. If those records are found in 1,000,000 years by something that can decode them, it will hear us before it reads us. That choice to lead with sound and music rather than pure data was also Sagan's. It was a decision that the most important thing to communicate was not our location, but our character. The selection of music for the Voyager record involved deliberate cross-cultural philosophy. Sagan's team included Beethoven's Fifth Symphony, Chuck Berry's Johnny B. Good, Azerbaijani folk music, a Navajo night chant, music from Senegal, India, Japan, Australia, Peru, Bulgaria. The selection was not random and not merely representative. It was an attempt to communicate something about the range of human experience, the fact that this species produces music in dozens of distinct traditions, each internally coherent, each representing a different relationship between sound and meaning. If you could decode those recordings without knowing anything about Earth, the music would tell you something about the cognitive architecture of the beings who made it before any data about their biology or their planet did. That is a striking thing to have sent. The Pioneer plaques announced our position. The Voyager records attempted to communicate our inner life. Both were sent before we had any confirmed evidence that anyone would ever receive them. Both were sent under conditions where the probability of discovery was, by any honest calculation, vanishingly small. They were sent anyway. That instinct to speak honestly into a silence that may never answer is one of the more distinctly human things we have ever done with the technology our civilization has produced. The universe has had 13.6 billion years to fill with signals. It is still quiet. That is the whole story. Return to the electromagnetic spectrum, radio waves to gamma rays, the natural medium of the universe, stars, galaxies, supernovae, pulsars, magnetars, quasars. All of them pour energy into the spectrum in patterns we have mapped extensively over a century of radio astronomy. The background noise of the cosmos is understood. We know what a star looks like in radio. We know what a galaxy looks like in microwave. We know what a pulsar looks like in X-ray. The signatures of every known natural process are catalogued. Against that background, what does technology look like? Narrowband emission. Natural radio sources are broadband, spread across frequencies, because the physical processes producing them do not concentrate energy. A transmitter concentrates energy by definition. The signature of engineering in the electromagnetic spectrum is a signal occupying a frequency range too narrow to be natural. That is the target. That is what Breakthrough Listen's instruments are designed to find. 1 million stars surveyed, 100 nearest galaxies examined, 0 confirmed narrowband signals of artificial origin. In 2020, Breakthrough Listen detected an unusual signal apparently coming from the direction of Proxima Centauri, 4.2 light-years away. The signal was narrowband. It was at a frequency not typically associated with human technology. It repeated across multiple observation sessions on different telescopes. For several months it was taken seriously. It was given the designation BLC-1 and scrutinized by an international team. It was terrestrial interference. The geometry that had initially pointed to Proxima Centauri was consistent, under more careful analysis, with a human-made source that happened to fall within the telescope's beam. The pattern held anomaly, scrutiny, resolution. The compounding barrier stack that Script 6 applied to civilizational contact applies here at the detection level as well. Signal degradation by the inverse square law reduces power over stellar distances. Temporal overlap requires 2 civilizations to exist in detectable form simultaneously. Frequency alignment requires both to be broadcasting and listening on the same channel. Technological going dark means advanced civilizations may become electromagnetically quieter as they develop more efficient energy use. Directional alignment means a targeted beam has to be pointed at us specifically during the brief window we exist to reach us. Each barrier is independent. Each is potentially fatal to detection. Together they multiply. And yet the absence of even one confirmed signal in a universe of 400 billion stars in this galaxy alone across 13.6 billion years is not what probability predicts if advanced civilizations are common. The compounding barrier stack explains why individual contact is hard. It does not explain why no incidental signature, no leaked radiation, no infrared excess from megastructure engineering, no waste heat from galaxy-scale civilization has appeared in any survey. Richard Carrigan at Fermilab searched the IRIS infrared satellite catalogue for stars with anomalous excess heat, consistent with partial Dyson sphere construction. He found 17 candidates. Each one examined in follow-up was consistent with a circumstellar dust disk. Natural. Jason Wright's survey of 100,000 galaxies found no strong candidates for Type 3 civilizations. The most visually anomalous star found in recent survey data, Tabby's star, has been shown by multiple independent analyses to be consistent with orbiting dust. The threshold is not ambiguous. The silence is not a narrow miss. It is a systematic, consistent, confirmed result across every method, every frequency, every scale. The spectrum is clean. It has been clean since we first had instruments capable of finding what should be there if our optimistic estimates are right. Whether that clean spectrum is good news or bad news depends on a question we cannot yet answer from inside it. And that question, which side of the filter we are on, is being answered by what we do next. Not by what we wonder, by what we choose. There is one more observational fact worth stating before the closing. It concerns not what we have found, but what the clean spectrum implies about the scale of whatever is doing the filtering. The SETI Institute's Phoenix project, which ran from 1995 to 2004 and was at the time the most targeted search in SETI history, examined roughly 800 nearby stars across a wide frequency range, with instruments sensitive enough to detect an Arecibo-class transmitter at 150 light-years. It found nothing. Breakthrough Listen has extended that search by orders of magnitude. The result is the same. The instruments are not the bottleneck. At the scale of the survey now completed, 1 million stars, a confirmed null result. The filter is not a local phenomenon. It is not explained by the specific conditions of our neighbourhood, or by a gap in the frequency range searched, or by a gap in the time window of observation. It operates at a scale large enough to produce the clean spectrum we observe across the full accessible survey volume. Whatever is filtering civilizations is doing it consistently at galactic scale across 13.6 billion years of time. That consistency is the most precise statement we can currently make about the Fermi paradox. The filter is real. The filter is systematic. The filter operates at a scale that our 65 years of listening has not found an exception to, and we are by every measure available squarely in the part of the chain the filter applies to. There is one final observational context that places the silence in its sharpest relief. The cosmic microwave background radiation, the afterglow of the Big Bang, is detectable everywhere in the sky. It was produced 380,000 years after the universe began and has been propagating ever since. It tells us that the universe, at its most fundamental observable level, is isotropic, the same in every direction, subject to tiny fluctuations that gave rise to the galaxies and stars we see today. Against that background, against a universe that has been producing stars and planets for 13.8 billion years, and that we can observe in every direction with equal sensitivity, the artificial electromagnetic spectrum is clean, not partially clean, not cleaner in some directions than others, clean in all directions, at all frequencies we can access, from all distances we have surveyed. The universe, which is 13.8 billion years old and contains enough stars to make our own sun's existence one among many billions, has produced no electromagnetic signature of technological civilization that our instruments can confirm. That is the observation. That is the entire scientific case. Everything else, the great filter, the dark forest, the self-destruction candidate, the rare earth hypothesis, is an attempt to explain that one clean observation. The observation is what it is. The explanations are what we have to live with while we wait for more data, or for the silence to break, or for the question to be answered from the inside by what we do next. 65 years of listening, one 72-second candidate that never repeated. The spectrum still clean. Those 3 facts open this. They are the same 3 facts at the end. Nothing has changed in the time it took to walk through every explanation physicists and astronomers have proposed for why the universe produces minds and then goes silent. The facts do not resolve, they accumulate, 2 readings remain, and they lead to different places. If the filter is behind us, we are the anomaly. The experiment ran on 400 billion stars across 13.6 billion years and produced us once, here, on this planet, at this moment. That is not comfort. That is weight. The weight of being the thing that got through when almost nothing did, in a universe that has been trying and failing to produce what we are for longer than the Earth existed. If the filter is ahead, the clean spectrum is a record. Every entry in that record is a civilization that reached our moment, that had radio telescopes and the ability to end itself, and did not get past the next few centuries. The record is written entirely in absence, in the signals that should be there and are not, in the megastructures that should be visible and are not, in the replies that should have arrived and have not. We are inside that record right now, the current entry, the electromagnetic flicker that has been broadcasting for 100 years and has not yet gone quiet. The universe will not tell us which reading is correct. The silence is the same either way. It does not distinguish between a galaxy that tried 1,000 times and failed 1,000 times, and a galaxy that produced us once and is observing, in whatever sense something without consciousness observes, what we do next. Every person alive right now is inside the window, not as a metaphor, as a physical fact. The specific interval of decades during which the choices that define whether a technological civilization persists or flickers are being made. Either this generation and the ones immediately after navigate the risks that the silence suggests most civilizations do not, or the spectrum acquires one more entry in the record of what tried and went quiet. The spectrum does not care. It received our first radio signal in 1895 when Guglielmo Marconi transmitted across a field in Bologna. It received the first radar pulses. It received the television signals of the 1930s and 1940s as they propagated outward. It received the Apollo program's transmissions. It received every satellite communication, every military radar, every broadcast in the last century. It has been accumulating our electromagnetic biography for 130 years, and in 13.6 billion years of galactic history, in the full observable universe with its 2 trillion galaxies and their hundreds of billions of stars each, the spectrum has not returned a confirmed artificial signal to us. 1 72-second wow, and then silence. What the spectrum does, what it cannot help doing, is record. It does not evaluate, it does not judge. It simply propagates whatever is placed into it and absorbs whatever is not. The clean spectrum is not an achievement, it is a record of what has not yet happened. Whether it remains clean because almost nothing succeeds, or whether it breaks open in some future century because something did, is the question that sits at the end of all of this. The clean spectrum has one property that matters specifically for the person listening to this right now. It is not a fact about the past, it is a fact about the present. Right now, as this plays, Breakthrough Listen is processing data. The Allen telescope array is pointed at the sky. The Green Bank telescope is listening. They are returning the same null result they have always returned, and they will continue returning it until either the instruments improve enough to reveal something that was always there and always below the noise floor, or something changes in the sky itself. The possibility that the silence breaks in our lifetime is not zero. A genuine signal, if detected and confirmed, would be the most important event in the history of the species. It would also, by the logic of everything covered tonight, raise a specific and immediate question. Which explanation does the signal represent? Is it a civilization that survived the filter, broadcasting from the other side of the threshold we have not yet crossed? Or is it something else, something the models do not yet account for? The silence breaking would not end the Fermi paradox. It would enter a new phase of it. The new phase would begin with, now we know they exist. The next question is, what did it cost them to get here? It will remain clean either way. It was clean before we arrived. It will be clean if we fail. It will be clean if we succeed and go dark on purpose, the way the dark forest logic suggests advanced civilizations do. It will be clean unless we cross the threshold and fill it deliberately with something that endures. 65 years of silence, 400 billion stars, one 72-second signal that never called back. The spectrum is still clean.